Hi, this is Stephen Brower from Irvine Valley Community College. This is for CSIT 256, Computer Architecture and Assembly Language. This is the overview for Irvine Chapter 9. The general theme of the chapter is support for arrays that is built into the processor. One thing we'll see, and let me jump ahead. There's going to be another video on the load and the store for signed double words. So load SD, store SD. And what that would allow us to do is we can read an element from one array, do something with that element, and then write the computed value, the new value, to the other array. In order for that to work, that load in the store, there's some setup that needs to be done. One is ESI needs to be set to the offset, logically the address of the source array. EDI is set to the offset, logically the address of the destination array. So those things are done first. ECX needs to be loaded with the number of elements that those arrays have. The assumption is that these arrays are of the same size. And what we need to do is set a direction. And what CLD will do will be, as it's using the load in the store, as it's processing the array, it will increment ESI and EDI. So with the CLD, ESI and EDI will be incremented to the next element. Well, if you're doing LOD SB, it adds 1. If you're doing LOD SW, it adds 2. If you're doing LOD SD, it adds 4. So it takes care of that for us. So the ESI and EDI have the source and destination arrays. The CLD or STD sets the direction. And by the way, if you are going to go backwards, the ESI and EDI should be set to the end of the array. So if you're going forward, ESI and EDI go to the beginning of the array. If you're going to go backwards, ESI and EDI are set to the end of the array. But you set your direction, you set your ESI and your EDI, and you set your ECX. And so this other video is going to take a look at the load and the store. I don't have a video for, but there is another demo that is for comparing two arrays. And so the demo file that is there, that one also uses the REP command for doing a repeat compare, which will keep doing as long as the comparison, as long as it's a good comparison, it'll keep going. So I don't have a video for that one, but there is a demo for that. As of the time I'm recording this overview video, I don't have a demo for MOV SD, and I don't know if I will. I may or may not. Stay tuned. Okay, so the middle of the book has, well, what the author did is he wrote, so using, I'm sorry, come back here again, using these commands for doing things like comparing, he wrote a number of string-based procedures for us to save us a little bit of time. And so the middle of his book, the middle of the chapter, is just sort of documenting that these procedures exist and shows how they're being used. Let me just skip over this for a second and talk about the latter part right here. So the latter part of the chapter has bubble sort and binary search. It's the assembly. So it has the code for sorting a one-dimensional array. It has the code for doing a binary search on a one-dimensional array. Now, a binary search requires a sorted array, which is why the sort is being done. So if you have a very large array and you're going to do a repeated number of searches on it, you can take the one-time hit to sort the array, and then the multiple binary searches after that will go a little bit faster. So the author has the code, and which also means it's in one of the demo files. 2D arrays. So there is a video, and there's a demo file that's associated with it that goes through 2D arrays. And one of the things it shows is logically how it would look. It does a comparison to what happens in Java. But I don't want to do a spoiler alert. There aren't 2D arrays in assembler. They're 1D arrays. And us as programmers, we have to manage that one-dimensional array as if it's 2 dimensions. You say, well, how do you do that? We got to go check out that other video. So that other video focuses on that. In that video, one of the things that's referenced is the set element of array procedure. And the net effect of that set element of array procedure is EAX is set with the row, EBX is set with the column, ECX is set with the value to stick into the array at that row and that column. It's a fixed number of steps to calculate the byte offset from the beginning of the array, and then it's able to put the value there. That set element of array is order 1. Okay, I just stole the thunder of the other video, but again, so that's the overview of Irvine Chapter 9, and it's all array support that the processor has.